All right. Good afternoon. I'm Damon. I'm from Slam Data, and I'm here to talk to you about our product. And I'm actually standing in lieu of Jeff Carr, who's our CEO and co-founder. He couldn't be here today, unfortunately. But hopefully, I'll do a pretty decent job, and you can't get your money back. You're already here anyway. So we've got a lot of good stuff to show you. I think we've got a lot of neat things that you're going to appreciate. So hopefully, everyone's awake and pay attention. Obviously, we only have standing room only in here. This is not really. I was actually downstairs about 20 minutes ago in the birds of a feather table, the analytics table. It was completely empty, so I was like a bird of a feather. And what makes it even worse is my last name is Lacaille, which is French. It's pronounced Lacaille, and it means the quail, which is a bird. So not only that, it's a fat ground nesting bird. So apparently it's a lonely one at that now too. So anyway, so let me get started about Slam Data. I'll spend about 5 minutes on the presentation, and then 15 minutes-ish on the demo, and probably 3 or 4 minutes or something for Q&A, and then we'll pass it over to Jay in Cloud9 Charts. Okay, Slam Data, and this is what I posit, is that it's the fastest, most powerful, easiest way to include analytics workflows, visualizations, charts, reports into your Couchbase application. And I'll tell you why in just a few minutes, but Prasad had actually, if no one's met Prasad, he's sitting there in the Couchbase shirt. He actually asked me to go over some of the basics real quick on where kind of the industry is, so I added a few extra slides here at the beginning. And so I'll go through those, and that way you can understand a little bit better why Slam Data is a unique proposition and solution. So currently, the vast majority of BI tools out there right now, you start off with getting all of your data sources, right? It doesn't matter what they are, NoSQL, Hadoop, APIs, relational, and you have all of this production data, terabytes of data, let's say. And the first thing you have to do, because you're working with this 30-year-old technology, 20-year-old technology, these BI tools, is convert the data. But first, you have to copy all that data from production to staging. So you've copied your data, and after you've done that, you transform it, right? The whole ETL process, you put it in your data warehouse, so now you've copied it twice, at least. You've sliced it and diced it, you've probably cut it up. You've probably lost a lot of the data already, and you've lost a lot of that rich, self-describing kind of nested data structure that you're using NoSQL in the first place for, right? Only so that you can use these old BI tools with modern data. It doesn't make sense. And then finally, you copy it a third or fourth time, maybe even more, into these data marts so that these tools can extract that data in this old two-dimensional format. And that's how it's been for a long, long time. It takes a lot of money, it takes a lot of time. I'm sure some of you have gone through this process. If not a couple of months, it could be over a year if you've got a lot of different data sources and you're trying to map all this stuff. It's crazy. So by the time you spent, let's just say 6 months getting something like this going, the business comes back and says, well, now we've got an extra data point, or we've got a new field or a column that we want to add and show up in our reports. Gartner ran a study and concluded, on average, that it takes approximately 8 weeks to add a new data point, any new data point. It can be just a number, it could be a string, whatever. By the time you enter it into your data source, by the time it's ready for BI tools to consume, it's 8 weeks. That's most of a quarter. Your business comes back and says, we want this data. That's too long to wait. So our founders, our co-founders, Jeff Carr and John DeGoes, took a step back. Can I get some water? Is there? Oh, thanks. So, thank you, Jay. So they took a step back and said, what would this look like if we could start off and work with modern data and just wipe the slate clean? And that's what they did. And this is what it looks like today with Slam Data. That entire ETL process is gone completely. There is no data relocation, no data migration at all. So that 8-week thing is gone. That 6-month-week thing is gone. You run a query, you run a search, it happens immediately on live data now. How does that happen? Well, with Couchbase and with Slam Data, there is no schema required. Obviously, it's a NoSQL data source. Slam Data uses a advanced analytics compiler, which does 100% pushdown of your request to the database. And why is that important? There's a lot of solutions that will translate what you're doing and push it down and then pull back some of the data. And once it gets it back, then it does some additional manipulation on it. And that's fine if you've got 100 megabytes, a gigabyte of data or something like that, right? Let's just say you pull back 10% of your entire data set. But unless you can push down 100% of the computation down to the end data source, you're going to pull back more data than you need. Let's just say it's 10%, not a big deal. But if you're running on 10 terabytes of data, you don't want to pull back a terabyte of data to run locally and try to crunch those numbers and stuff, right, inside of your BI tools, whatever those are. So it's important that as your data scales, that your solution scales as well. And so when you have 100% push down of your computation to the database, the bigger your deployment gets, the more powerful it gets, the more powerful SLAM data gets, because we push everything to the database and we only bring back the results. And that requires advanced technology. This is really where the innovation comes from at SLAM Data. It's our SQL squared dialect. It's our Quasar Analytics compiler. We've got a number of technologies that are highly advanced that we use. They've been in process for over 3 years now, being in development. And so what happens is we just return the results. And so that means if you're running selects and group bys and averages and offsets and limits and joins and everything else, we push all that, and then we only get the results. And then we show you those results, and that's huge. SLAM Data understands any type of data, whether it's relational, whether it's JSON, XML, CSV, doesn't matter if it's from a cloud API or Hadoop. Right now we're focused on Couchbase. We're really excited about coming out with our connector. It runs really extremely well. And that's what I'm going to demo for you here in just a few minutes. And the other thing about SLAM Data, well, there's a lot of things, but the other thing is it's 100% open source. So you can go right now to slamdata.com, go to github.com, clone the repo, download the code and build it. You'll be running in about 20 to 30 minutes. It's super simple, runs on all the different major operating systems. And so let me just show you really quick, just an animated graphic. This is a workspace we created in about 20 to 30 minutes for a Department of Defense customer or partner. What it is, it's showing real live data from warfighters, and this is all nested data inside of Couchbase. And so what it's actually doing is you're selecting the patient, and it's getting this data live. And then you can see it shows a line chart, gauge charts, all this kind of stuff. Now, it's not the most beautiful charts, I'll admit, but it took 20 minutes to create this. And you can embed this inside of any application that you want. It's really an analytics application builder, if you think about it that way. There's all sorts of stuff you can do with this, and I'll show you some of those. You can embed anything you create in SLAM Data into any other application. It's built for embedding from the ground up, and I'll show you some of those examples. And all of this is with the open source version. So how do we make money, right? That's with the R Advanced Edition. And so we offer everything the open source edition offers, but we also add authentication and authorization and auditing. We use OAuth 2 and OpenID Connect providers. Google, Facebook, WordPress plugins, all these things, and most people have an OAuth 2 authentication mechanism inside of their IT environment. It's built from the ground up from front to back for multi-tenant security. And the entire SLAM Data solution, from the compiler on the back end and the connectors to the charts on the front end and even the configuration screens, understand nested data completely. So you don't have to go back and do all that ETL. You're not limited to just 2 dimensions. And I'll show you examples of those as well. You can run SLAM Data on server, laptops, bare metal, virtualized, doesn't matter. All the major operating systems. And again, this is the secret sauce, MRA, multidimensional relational algebra. That's long for Murray, and that's actually Murray in the lower right corner. It's a real dog. It's actually our mascot. It's a cute little pup. And this is the foundation of everything that SLAM Data does, from the front to the back. This is an extension of relational algebra. It's not a complete wipe clean and create something new. So that means we can connect to relational databases and talk to them, but it also means, because it's multidimensional relational algebra, it's way too complicated for me, but it does mean that we can use deeply nested, schema-free, semi-structured data with analytics. Okay, that being said, let's just jump into the demo. All right. So what you see here, let me jump to the home screen. So we apply a virtual file system across all of your data sources. Right now I have a Couchbase server mounted locally on my laptop, and I called it Couchbase. You know, if you think about it in Windows or Unix terms, it would be like slash or C drive or something like that. So you click into the mount, and then you see your buckets. I've got demo 1, demo 2. We click on demo 1 here, and you see a couple things. You see a couple workspaces that I created yesterday for this, and then you also see patients and time series. What those are logical views or actual views of document types inside of that bucket. So if I were to click on patients, actually let me show you this. This is what the document format looks like. So we've got a couple top-level variables. We've got this codes array, with a bunch of data inside of it. So you can see it's, it can be deeply nested. And I don't need to know what the schema is. I just connect to it. I click on, let's say, patients. We'll give it a name of patients data, something simple. Click Explore. And it creates what we call a workspace. And what you're seeing here is the Explore table. And it's a two-dimensional representation of that multidimensional data. We also have a pivot table, but by default, it just shows you this. And you can see automatically it recognizes all of the deeply nested data, as you see here. You can see all of the top-level data as well. And I haven't done anything technical, right? I've just clicked on information. So I clicked on that document type. What we build on is this metaphor of a deck of cards or multiple decks of cards. What you're looking at is the topmost card in this deck. So I'm going to slide this card over. And we're going to add a new card on top of that, and it's going to be a chart card. We're going to set up a chart. We'll go with, this is the patients, yeah, so we'll go with a bar chart. We've got, over a dozen different types of chart types. We add about one, now that we've conquered this kind of data problem on the back end, which is the part that took 2 years, basically. Adding charts, it takes about 2 weeks to add a new chart, maybe a little bit less. So every time we come out with a release, like a .1 release or .2, you usually find 2 or 3 new chart types. So on this one, we'll select state as a category. Again, you can see all the nested data here, but we're going to separate it on state. And we're going to measure it by the age of people, but we're going to do it on the average age of people, not the sum, because we don't want to see 70,000 years old inside of there. And then we're going to split it up by gender. So just with a couple clicks, right? And then I'm going to advance this card and click Show Chart. And so what you're seeing here is 100% push down of that query down to Couchbase. It didn't do anything locally. So it didn't pull back the data and manipulate it at all. It was multidimensional data, right? And we're aggregating on that. This is, interactive in the sense that, you can hover over it and see the values. You can, turn the legends on and off. You could even, right next to it, have the actual raw results sitting next to it. And anything you create inside of SLAM data, like I said earlier, is completely embeddable in whatever you do. So to do that, I just, what we call flip the deck. And I can do embed the deck, or I can do publish deck. And so you do publish, you can just take this URL, give it to your coworkers, and they can go look at what you've created and interact with it. And it's really simple. And then the embed deck I'll show you in just a minute. And that's a little more advanced, but it's still very, very fun to play with. OK, so here's a time series. So we'll do the same thing. We'll just click on this time series. We'll just call this something like IoT data. Now this is pretty flat data, but it demos pretty well. It's pretty easy to demo. So I'm going to do the same thing I did before. Set up chart. Set up the area chart now instead of a bar chart. We'll categorize on the date timestamp. The measure will be value and the sum. And then we're going to split up the series based off the name of the sensor. It all looks good. I'll stack the data, make it a little smoother, advance a card, show chart. Give it a second to render. So, and again, as you hover, you can see the values underneath, and all the data is interactive in terms of the series. So again, without knowing any kind of query language at all, I was able to look at this data in Couchbase and pull it back and visualize it. Again, I can embed this in any application I want as well. So let me show you a couple more examples that I created, like I was talking about. So here, we've got the patient's data set, and we have a little bit more interactivity. So we've got the listing of distinct names of states. So if I click one, like Georgia, you'll see that it updates the table here and updates over here. Pretty easy to create. Now this one did actually require a query, because if I go back and I look at the source, we're taking this state variable and we're populating it with a query. So it actually populates that dropdown with the results of a query, which is super fun to play with actually in this workspace editor. You can do all sorts of neat things. And then also, we've got this little IoT sensor report. Once it comes up. With our workflow editor, you can create all sorts of different UI elements like drop-downs here for dates, calendar pickers, check boxes, radio buttons, all that good stuff, text entry. And again, even here, we've populated all of these sensors with a query. So if you added a new sensor tomorrow, sensor 7 or sensor 8 would show up. The nice thing about that is to embed that, like I was talking about earlier, we flip the deck, we click Embed Deck, and SlamData gives you 100% of the code to copy and paste into your file. And most of it, just this bottom part really is the key part for individual stuff. The top part can actually be included in some type of JavaScript file. It's pretty generic. So as an example, I'll go over here. And I just spoiled it. You just saw it. So I'll go to the IoT sensor report because it's been embedded there. And you can see inside of this application, it's pulling over that workspace and showing it. It's still fully interactive, meaning you could select, once it comes up, you can select the different raw data. You can select a different date. And as soon as you select it, again, it's running and querying off of live data. Let it update here. And you can see all the data underneath. So that's the power of SlamData. In about 2 minutes, you can connect and create these types of charts. The more complicated charts may or may not require a little bit of query. We actually use a dialect called SQL Squared, which is a multi-dimensional type of version of SQL. And let me show you what that kind of looks like, actually. Here we go. What the SQL actually looks like behind the scenes, if you'll remember, this couch-based data model has this codes array. And this is how we query something like that. Let me zoom in a little bit. You can see here, we've got that codes array, and then we use this operator. This is one of many operators that we provide in SQL Squared. It basically means go down into every document inside of that array and look in the description field inside of that document, and we're doing a substring search for flu. So basically, we're just showing who has the flu in different states in this data set. Pretty simple little query. But let me zoom out a little bit again. Again, you can take that and you can embed that exactly into your reporting as well. So it can get very complex. It has incredible versatility. We've got the Couchbase analysis service. We're already talking with Couchbase and their engineering team, product management. I don't know if any of you have stopped by the analytics booth downstairs and talked to Abdullah yet, but it's pretty exciting stuff. It's a developer release was just, I think, a couple days ago or something, I think, for this. And our engineers are already working on it so that when it's ready, whenever Couchbase has it ready, we're going to be able to transition back and forth depending on which solution is the right one. So if you've got maybe a smaller data set, it's going to use the nickel and that port. If it's a larger data set, it'll use the analysis side, and use that port with the SQL++ or whatever. I don't know a whole lot about it right now. I've just been told what is going to happen. So again, this is future-proof, essentially, right? I mean, it's open source. You can download it right now. It's probably the most powerful piece of software I've used in terms of database analysis ever, and I've used quite a few. I've worked a couple database companies. So let me wrap up with 1 or 2 slides, and then I'll take some questions. Okay. Okay, after all this, I know it was kind of a bit of a whirlwind. I'm not sure where we're doing on time. We probably have a few minutes for questions, I guess, still. So let me run over a few points, and then I'll take some questions. You should go get it now. You should download it. You should build it. There's no reason not to, right? It's free. Why wouldn't you? 100% ANSI-compatible SQL, in addition to our operators that you can use on either relational or nested data. We do 100% pushdown. Again, this is for scalability purposes and for power. It's where our power and flexibility comes from. Your data grows, your environment grows, we grow. You don't want to pull back even 2% of your data. You just want to pull back the results. Let your database environment be the workhorse and do all that computation for you. Doesn't matter what your schema is, XML, CSV, JSON, new data format comes out tomorrow, we'll be able to support it immediately. Yeah, a week. 100% embeddable in your applications. We have cross-data source queries. I have another workflow that I didn't show you that it's pulling from multiple data sources. Our workflow editor, which you didn't really see, dozen chart types, Google-like search functionality, which if we've got another minute or so, I'll show you what that looks like. But there's so much that you can play with and explore and find all those little nuggets of data that are important to you without pulling down all that data locally. It's super powerful. So if you have any questions, I'd be happy to take them at this point. Yes?
How do you correlate different data sources, input coming from different data sources? How do you map, like, for example, it may be user underscore ID in one, user ID without the underscore in another. So how do you correlate stuff like that coming in?
So the question is, how do you correlate different data sources coming in? So as an example, I'll give you an example of something, and maybe it may or may not apply. So if we have, we can use the actual field names, of course, when we do the queries. We can give them aliases, of course. We can do joins and all this. But if you're using, let's say, two different data sources, let's say they're both Couchbase, but they're in different regions or something, or different buckets or something, that virtual file system I was talking about earlier is what you use as the path. So it might be Couchbase 1, Demo 1. The other one might be Couchbase 2, Demo 2. You could either do maybe a join on those, or you could pull back different data sets from both of those and display them in different charts. Is that kind of getting towards the answer?
What if I try to get something from Hadoop and Couchbase at the same time and try and correlate that?
If you try to get, say that again?
If I try and get something from Hadoop or maybe a CSV file and also from Couchbase.
Oh, okay. I think I see where you're going. So there's two different things. So we do cross-data source queries right now. Cross-data source joins are coming. So the federated queries and federated joins, things like that, that's coming soon. It's not there yet. So when you correlate it, you can correlate it in the sense of if you've got one overarching ID that can be used in both data sources, of course, you can use that to pull that data back. But again, this is 100% SQL, ANSI SQL, so you can run case statements inside of there and change things on the fly. We actually have a demo here that I haven't shown you that changes the fields that you're pulling back in the select clause based off of information that's being passed into the workflow from an API. There's a lot of flexibility that you actually haven't seen here, and I wish I could demo it for you a little bit more. But the embedding, you can control what people see. You can control what data sources you're having access to based on who's logging in, and change the query path based off of that. There's all sorts of flexibility inside of there. So talk to me afterwards. I'd love to expand on it too. Other questions? Joe in the first row? Pardon? Yes, it is using NCCL behind the scenes. So we take SQL Square, we take whatever you do inside of SLAM data, and we convert that basically in the compiler. And in this sense, it's converting to NCCL and being pushed down to Couchbase. Yeah, that's pretty much the database conundrum, right? All the time is it the software, is it the hardware, is it the database? It's going to rely, again, 100% on your Couchbase deployment. So if there's not an index there, it's going to probably run kind of slow. Yeah. So, but on the flip side, if you've got your right indexes and you've got your right deployment strategy set out, it's going to be really, really fast. It's going to be even faster once the analytics service is available. Yes, sir.
As far as hardware architecture, is there like when you were demoing it, is there like is it going to some kind of server, then it connects to the data sources from there, and then it serves it up and renders it for you?
Yeah, good question. Let me kind of summarize how it works. Basically, you got another minute? Can I spend 1 minute?
Maybe this will be the last question because we have one more session actually, right? Okay, we can
Yeah.
take the questions offline.
Yeah, so just, and that's something I should probably include in the talk, is we've got the front end, which is a full HTML5 application. It talks via REST API to our analytics compiler. The analytics compiler then has these QScript connectors. It uses a new technology we've developed, which does a lot of the that universal kind of abstraction layer for all the different data sources. And so depending on if you're using Couchbase or some other type of connector, it's going to convert it at that point once it reaches there. So all the way from the front end to the connector, it's going to be everything we do. And from here out, it's going to be whatever that end data source is going to be. What was the specific question, though? I don't think I actually got to it.
I guess the connector itself, where is that running? Is that running on?
Oh, right, yeah, the architecture. So right now, I've got everything running right here. When you deploy it, you've got a couple of choices. Normally, SLAM data is deployed as one kind of jar file, essentially. It runs inside of a JVM. It's written in Scala. It's 100% pure functional programming. But it runs on a JVM. You can split it up between the front end and back end if you really want to. Right now, one implementation, one installation can handle thousands of users concurrently, running these queries and consuming reports and stuff. So it's not terribly burdensome, on the system resources. It's pretty low. In fact, it's like 2 gigs of memory is our recommendation. You usually don't need that. And then maybe 25 megs for every concurrent user. Just enough heap space memory so that you can show the charts and stuff. Okay?
Great.
All right. Well, thank you very much.